Today we're covering 7.2 perpendicular lines. Okay, so if you haven't figured it out by now, if two lines are perpendicular, it means that these two lines will form a right angle just like so. Okay, at the point where they intersect each other. So we can go through this in class on the proof of it itself, but what you do need to know is that in order for us to something special about perpendicular lines is if you take the two gradients and you multiply them together, so gradient 1 times gradient 2, the product, okay, of these two gradients will be equals to -1. Okay, that's it. Okay, so what you need to memorize is for perpendicular lines, the product of the gradients is -1. Let's see how we can actually apply this right in for some problems itself. So now, for example 4, they say find the equation of the line through 2, 3. Okay, this one that's perpendicular to this line. So first and foremost, okay, the gradient of this line itself, the gradient is equals to half. So if I know that the line through P is perpendicular, I'll say M times half is equals to -1. So the gradient itself is equals to -2. So therefore this line M is equals to -2. Now, if you remember how to find the equation of a line, we use the point P, y minus 3x minus 2 is equals to -2. Then very quickly, y minus 3 equals to -2x plus 4. Y is equals to -2x plus 7. And that is the equation of the line through P and perpendicular to the other line. Now, we want to find the coordinates of F. So F, if you notice, is the intersection between this line and this line, and for that line through P, we now know that y equals to -2x plus 7. This is an issue whereby we can resolve this by applying and solving them as simultaneous equations. So this is equation 1 and it's equation 2. So I put equation 1 is equals to equation 2. Very quickly now, if I solve, okay, my x value is 2 and 2/5. And similarly, if you take the 2 and 2/5 and substitute this into this equation or this equation over here, you'll find that the y value itself is 2 and 1/5. Hence, okay, F, all right, is 2 and 2/5 and 2 and 1/5. You could have left it as 2.4 and 2.2, but I much prefer fractions because it's it retains the accuracy there. Now, the last part is for part 3. Okay, part 3 is to find the distance P to the line F. So, what is the shortest distance? The shortest distance in this case from P to the line F is quite obviously just this distance, the perpendicular distance. So if you want, let me just go and highlight this. This is the distance that I'm trying to find. So if my P value was 2, 3, and from the earlier part, the F value is 2 and 2/5 and 2 and 1/5. What I can do is to apply the distance formula. x2 minus x1 square plus y2 minus y1 square. I square root all of this. Whoops, not so nice. Let me try again. I square root all of it. What I'll get for my PF value is square root of 4/5. So it gives me square root 4 over square root 5 is 2 over square root 5. If I multiply both the numerator and denominator, and you don't need to do this, but if you want to, you simplify, okay, what you will get is 2 root 5 over 5 units, and that in itself is the shortest distance. Okay, I urge you now, okay, to pause the video and look at this try 4. And when you're ready, please unpause the video and I will go through this question. Okay, now I go through try 4. Find the equation of the line through A, -2, 4, and perpendicular to the line 3x plus y minus 1 is 0. Hence, okay, first and foremost, what I'll do is, from the very first line, what I can do by rearranging the equation, okay, what I can get is y equals to negative 3x plus 1. So, if the gradient of the perpendicular line is negative 3, so m times negative 3 equals to negative 1. So the gradient of the line through A, the value of the gradient is 1/3 over here. So what I can do is to apply my formula. So through A is y minus 4x minus negative 2 is equals to 1/3. Simplifying will give you y equals to 1/3 x plus 14 over 3. Now, if the two lines intersect at the point N, what we are hoping to do is to solve simultaneously. And if you do that, okay, you just solve the line simultaneously, what we'll get is x equals to negative 1.1 and y equals to 4.3 or 4 and 3 over 10. Last but not least, the shortest distance. So A to the line is basically A to the point where they intersect each other. And as we have known, the point that intersect each other comes from here. Negative 1 and 1 over 10, 4 and 3 over 10. All that remains is for you to apply the distance formula with negative 2, 4 and negative 1 and 1 over 10, 4 and 3 over 10. What you get is this 3 root 10 over 10 units for the shortest distance. I think this is not too difficult. So let's move on to example 5. In example 5, there's a trapezium ABCD, ABCD. Here's where I need to teach you something. Usually, okay, not usually, always, they will go in a certain direction. So for example, when we name shapes in mathematics, A, B, C, D, they will flow in a certain direction. So in this case, it's flowing, what I call in a clockwise manner. That's why A, B, C, D. There is never any case whereby we name A, B, then you cross over to C, then go back to D. A, B, C, D, it will not occur. Okay, so it will always go in certain. And why a certain, what I call a direction, and why we need to speak of this is because there are times whereby we are supposed to find the coordinate, and we need to make some inference as to where the coordinate is. So for example, it's given A, B, C. So you will know that since they are naming in a clockwise manner, D must be somewhere down here, okay, or here, but it goes in a clockwise fashion. It's not possible whereby here is A, here is B, here is C, then out of nowhere D is somewhere else. So it's A, B, C, D. I mean, what shape is this? Okay, so it has to follow in a certain direction. It does not necessarily need to be clockwise. Sometimes it can actually flow anti-clockwise as well. All right. Okay. Now, in this example 5, it shows a trapezium ABCD in which AB is parallel to DC. The point A lies on the y-axis. Very important. At the y-axis, what do we know? The x value is equals to 0. Now, the points B and D, okay, are given. The sides A and B are perpendicular to BC. Given that the equation of DC itself is y minus 2x plus 7, so let's just label it. Okay, it's already labeled for you over there already. Now, what we want is to find the equation of AB itself. So now, since I got the line DC, notice that DC is parallel to AB, which means that they have the same gradient. Okay, so now from DC, let me just use the point y minus 2x. Okay, I did something wrong there. There's a boo-boo. Okay, y minus 2x plus 7 equals to 0, y equals to 2x minus 7. So the gradient of DC is 2. Since they are parallel, gradient of AB is also equals to negative, is equals to 2 as well. So gradient of AB is equals to gradient of CD is equals to 2. So this gradient also equals to 2. Now, I have a point 6 and 15 of the gradient. What I have to do is to apply. So, y minus 15, x minus 6 equals to 2. If you solve everything, what we get is y equals to 2x plus 3. Hence, AB has the equation of y equals to 2x plus 3. So down here, let me just label y equals to 2x plus 3. Now, I'm trying to find the equation of BC, not a difficult question. I already have the point passing through BC, which is 6 and 15. So I notice that AB and BC are perpendicular. And remember, for perpendicular lines, m1 times m2 equals to -1. Hence, 2, okay, let me use a thicker nib. Okay, 2 times m equals to -1. M is equals to -1/2. Hence, the gradient of BC, the gradient is -1/2. Then, y minus 15, x minus 6 equals to -1/2. If I simplify all of this, what I'll get is y equals to -1/2x plus 18. This is equation of BC. Now, find the coordinates of A and of C. Now, just remember, this is y equals to 2x plus 3, and this is y equals to -1/2x plus 18. To find A is a simpler one. Okay, remember what we said earlier. At A, along the y-axis, x value equals to 0. I substitute into the equation itself. So I'll say sub x equals to 0 into y equals to 2x plus 3. So y is equals to 3. Hence, A is 0 and 3. Now, we need to find the coordinates of C now. Okay, so to find C, notice that the equation of BC is given by this, and the equation of CD is given by this equation as well. So what I need to do to find C is to use y equals to -1/2x plus 18, and y minus 2x plus 7 equals to 0. So I can actually simply sub equation 1 into equation 2. So y minus -1/2x plus 18 minus 2x plus 7 is equals to 0. So what we get is -2.5 is -5 over 2x is equals to -25. So my x value in this case is equals to 10. So I just take the 10, I substitute into here. I will find that my y value itself is equals to 13. Hence, the value of C is 10 and 13. Okay, now, so I got A is 0, 3, and C is 10 and 13. So A is 0, 3, and this is 10 and 13. When we move on to a later part in 7.4, I believe there will be a simpler way to do this question, whereby we will actually find, we can actually use the formula, or just 7.4 itself, okay, the areas of triangles and quadrilaterals. There's something called the shoelace method, okay, whereby we can actually apply a given method of calculation to calculate this base shape, the area of the shape, based on a formula. However, for this present moment in time, we have to do certain things that are more, how I put this, convoluted. So I just explained to you, I won't show you all the working itself, but basically it works like this. If I have this point and this point, I can calculate the length of AB using this formula. Okay, so I just imagine that I've done that, and I will find that my length of AB is square root of 180 units. Similarly, I can apply the formula to B and to C, and I also find that the length of BC itself is square root of 20 units. And C and D, if I want to find the length of this shape, the length of this shape itself for C and D, it will be this line is root of 320 units. So if I were to find the area in this case, so the area is equals to the length of AB plus the length of CD divided by 2 times the length of BC. A plus B over 2 times height. So AB itself is square root of 180 plus CD is root of 320 divided by 2 times the height, which is square root of 20. Then if I just I just multiply in the square root of 20, so I get square root of 3600 plus square root of 6400 divided by 2. Then what I get is 60 plus 80 divided by 2. So 60 plus 80 divided by 2, I will get 70 units square. Okay, that is one way. It's a bit convoluted, but I think it's perfectly doable. The other way is to figure out from the coordinates, okay? Like for example, okay, A itself, all right, A itself we calculated was 0, 3. Okay, then you can actually use the coordinates itself to figure what are each of the lengths. So for example, we found that D is 2 and negative 3. So if D is, if D is 2 and negative 3, it means that this portion here is 2. Okay, here to here is negative 3. Okay, and here to here, A was 30. So this not drawn to scale. This unit is 3. So hence, from A to this point D, okay, for the vertical part, right, okay, it is actually 6 units itself. Alright, so it's 3 plus 3 is 6 units. Hence, you can actually go around and start to figure out what all of these lengths are. So basically, the whole rectangle, this rectangle here, the number of the units here will be 10, okay, times 16 equals to 160 units square. So if I have 10 times 18, not 16, 18. So 2 plus 6. So here is 10, here is 18. So 10 times 18 is 180 units square. So now what I can do is to figure out, right, each of the different triangles. For example, this triangle over here is half times 12 times 6. So this triangle here is worth 36 units square. This triangle 2, 4, okay, so this triangle, the area is half times 2 times 4. This is 4 units square. So basically what I can do to get my area is equals to the whole rectangle itself, which is 10 times, let's say 18. Okay, what I need to do is to slowly minus away the other areas that I do not want. Okay, so it is minus 36, okay, minus 4, minus 64, minus 6. Okay, so what I'm doing is to minus away the area of these 4 triangles. So my area in this case will also give me 70 units square, which is the same value. But don't worry too much about this. We'll come to the shoelace method again soon. Alright, okay, now I will pause this video, then I will finish up with a part 2.